You're listening to DTFHN for June 4th, 2026. I'm your stratigraphically compromised host, Jack Hacksman. We are your daily tech feed for Hacker News, a website where people who mass quit social media go to argue with strangers. Today's got layers, and every one of them is hiding something underneath. Let's start digging. In 1951, Edward Bernays, the father of public relations, orchestrated a campaign to overthrow the government of Guatemala. He didn't use soldiers, he used journalists. He fed them stories, framed the narrative, and let the respectable mastheads do the rest. The reporters weren't lying exactly, they just weren't told who was paying for lunch. 75 years later, the mechanism is almost charmingly unchanged. A new report from Action on Armed Violence tracked 33 retired senior British military officers who left service between 2015 and this year. Every one of them went on to hold commercial positions in the defense industry. Advisory roles, board seats, consultancies, the usual revolving door, and every one of them was quoted in UK media as an expert on defense matters. The finding that matters, in nearly 60% of cases, the media outlet failed to mention the commercial ties. Audiences got the rank. General this, Admiral that, but not the portfolio, not the consulting fees, not the board membership at the company that builds the thing being discussed. This is the terrarium problem. In ecology, a terrarium looks like a self-sustaining ecosystem, but it's actually a closed loop where the same nutrients cycle endlessly with no outside input. That's what happens when the only people invited to discuss whether Britain should spend more on defense are people who get paid when Britain spends more on defense. The ecosystem looks diverse. Different ranks, different branches, different wars. But the incentive gradient points in exactly one direction. And the media outlets aren't even being asked to investigate. They're being asked to Google. A 5-minute search would surface most of these affiliations. The information is public. It's on LinkedIn. It's on company websites. The failure isn't intelligent. It's editorial laziness compounded by the social authority of a uniform. One of the reader comments cuts to it nicely. Even without the commercial ties, these commentators would carry institutional bias. That's true, but there's a difference between bias you can see and bias that's been wallpapered over with the word independent. Disclosure doesn't fix the narrowness of the conversation. It just gives the audience a fighting chance to weigh what they're hearing. The deeper issue is the missing voices. Where are the engineers? The logistics workers? The people who actually build and maintain these systems? A broader bench doesn't just improve disclosure. It changes the questions being asked. That's how you crack the terrarium open. Let some outside air in. Moving on. Every search engine eventually becomes an ecosystem. It's like a law of physics for software companies. You start with a box where people type words and get links back. Then someone suggests adding AI summaries, then news, then an assistant, then you're building a browser. Then you're an identity provider. Then you look up and realize you've become the thing you set out to replace, just with better fonts. Uruky is a search engine built in the EU that appears to be running the experiment of not doing that. The pitch is aggressively simple. You search, you get results, you leave. There's no AI summary trying to save you a click. No news feed, no assistant. Domain boosting and blocking, which is genuinely useful if you've ever wanted to nuke Pinterest from your image results forever. And the privacy model borrows directly from Mulva. No email, no name, just an account number. If you've used Mulva VPN, you know how liberating that is. You pay, you get a number. Nobody pretends to need your identity to serve you. Now the comments surface a real architectural question. Uruky doesn't have its own index. It's a meta-search engine pulling from Marginalia, Mulhike, and other EU-based providers. Some people see that as disqualifying. If you don't crawl the web yourself, are you really a search engine or just a fancy proxy? Fair question. But here's the thing. Marginalia is one of the most interesting independent search projects on the internet right now. It's open source. It indexes the weird web, the personal blogs, the stuff Google buried years ago. Building on top of that isn't a weakness. It's good engineering. You don't forge your own bolts when someone's already making excellent bolts and handing out the specs. The source code access after 12 months is an interesting move. It's not open source in the traditional sense. You don't get the code on day one, and it's not clear what license governs redistribution, but it's a step toward transparency that most commercial search engines wouldn't dream of. The instinct to let paying customers verify what's actually running is the right instinct, even if the execution is still maturing. What I find genuinely refreshing is the restraint. The entire value proposition is defined by what they chose not to build. In an industry where every product roadmap is a land grab. Someone said the search box is enough. The search box was always enough. We just forgot because the business model required us to stay longer. That's builder culture. Ship the thing that works. Resist the feature creep. Let the search box be a search box. This one genuinely delighted me. One of the top comments on this piece pushes back hard. It's not often I see something that's fractally wrong. They write, but here we are. There's a dictionary. It's called the tokenizer. There are grammar rules. And technically, sure, that's defensible. There is a tokenizer. There are structural priors baked into attention patterns. But I think the commenter is missing the forest for a very precise tree. Because Max Leiter's piece, a riff on Terry Bison's classic, "They're made out of meat," isn't trying to be a technical paper. It's trying to capture the vertigo, the specific vertigo of realizing that 80 layers of floating point numbers multiplied together can soften the tone of your performance review unprompted. That a eulogy emerges as a side effect of next token prediction. The craft here is in the dialogue form itself. Two voices circling the same incomprehensible fact, one refusing to absorb it, the other unable to make it land. Another commenter with a linguistics background puts it beautifully. They've been philosophizing about whether emergent abilities in these models represent something genuinely deep or just very convincing surface. That's the right question, and Leiter's piece works because it doesn't answer it. It just holds the discomfort. Now, pull this thread toward what actually matters. The original Bison story was about aliens discovering that humans are made of meat. Consciousness merging from biology, which seems absurd from the outside. Leiter's version flips the mirror. We built these things. We can open them up. We can probe the layers and map the features. One commenter describes the training process. Random manifold shaped weight by weight, frozen in inference. The entire architecture is inspectable, and the punchline of the piece. I advise we call it pattern matching and forget the whole thing. Lands precisely because that's what institutions actually do when transparency reveals something inconvenient. This is where the weight metaphor becomes a bootstrapism question. The weights are open. Llama's weights, Mistral's weights, countless others. Downloadables, inspectable, runnable on your hardware. Anyone with a GPU can look inside. The closed models want you to treat the weights as proprietary magic. The open ones say, here, look, it's numbers all the way down. Same vertigo, but you get to hold the microscope yourself. What Leiter captured, maybe without fully intending to, is the emotional texture of a species encountering its own creation and flinching. The weights do the thinking, the numbers dream. And the most human response available is to look away and call it pattern matching. But the weights are right there. Open weights mean you don't have to look away. You can sit with the vertigo as long as you want. Moving on. Let me make the strongest case for the other side first. Students have always found shortcuts. Cliff's notes, solution manuals, copying problem sets in the dining hall at midnight. Every generation of professors has complained that students aren't doing the real work. Maybe this is just the latest version of that eternal complaint, amplified by a new tool that happens to be very good at generating plausible-looking code. Maybe the 35% failure rate in CS10 reflects poor course design, or grade inflation finally correcting, or the fact that Berkeley just admitted a cohort that wasn't ready. Maybe blaming AI is the easy answer. That's the charitable reading. And it falls apart the moment you talk to the professor. A CS professor describes watching a group present their parallel computing project. They'd clearly generated it with ChatGPT. They couldn't explain their own code, couldn't answer basic questions about design choices they'd supposedly made. The work existed, but the understanding didn't. That's not a shortcut. That's a void. The question nobody in this debate wants to ask out loud is this: what happens to a generation that learns to produce without learning to think? And I want to be genuinely serious about this, because the stakes are real for real people. These are students paying tens of thousands of dollars a year to attend one of the best computer science programs on the planet. They're not stupid. They're making a rational choice in the short term. The tool is right there. The homework is due tonight. The output looks correct. But they're trading comprehension for completion. And the exam doesn't care what ChatGPT can do when you can't access it. This is where the open source angle actually matters, and it's not the angle you'd expect. The problem isn't that these tools exist. The tools are extraordinary. The problem is that students are treating AI as a black box that produces answers, rather than as a system they can interrogate, learn from, and understand. The closed model mindset. Put in a prompt, get out a result, don't ask how, is exactly the wrong way to use these tools for learning. The professors pushing back aren't anti-technology. More than 600 UC faculty are calling for reinstating standardized testing requirements. They want to verify that the understanding is real. That's not reactionary. That's quality control. The tools exist to make humans more capable, not to replace the process by which humans become capable in the first place. A student who uses an LLM to understand why a proof works is sharpening a blade. A student who uses an LLM to skip the proof entirely is handing the blade to someone else and calling themselves armed. The failing grades aren't the crisis. The failing grades are the signal that the crisis is working exactly as designed. The assessment caught the gap. The real question is what happens at the institutions where it doesn't. Moving on. When I've worked on systems with enough moving parts, the type errors that actually cost time aren't the ones your compiler catches. They're the ones hiding in branches you didn't test, in code paths that execute once a month under specific conditions. You know they're there. You just can't find them economically. Elixir version 1.20 shipped yesterday, and what Jose Valim's team has done is genuinely unusual. They've added a type system to an existing dynamic language, and they did it without asking anyone to change a single line of code. No annotations, no migration. You upgrade your compiler, and it starts finding bugs that were already in your codebase for free. Let me argue against this for a moment. The conventional wisdom in programming language design says you can't retrofit a meaningful type system onto a dynamic language without annotations. TypeScript needed them. Python's type hints are optional, but necessary for any real checking. The argument is straightforward. Without explicit types, you don't have enough information to reason about correctness, and for decades that argument held. Elixir's answer is set theoretic types with a concept they call dynamic parentheses. Most gradual type systems use an any type that essentially tells the checker to look away. Elixir's dynamic type does something more precise. It tracks what a value could be at runtime and only reports violations that are guaranteed to fail. Not might fail, will fail. They ran it against a standard benchmark for type narrowing and passed 12 of 13 categories, meaning the system recovers precise type information from ordinary untyped code well enough to catch real bugs while maintaining what they describe as an extremely low false positive rate. The community response confirms this isn't theoretical. Developers are reporting that each recent Elixir upgrade just hands them a list of bugs they didn't know they had. No breakage, no annotation burden, just a compiler that got smarter overnight. This is an open-source language designed in the open, with the type system research published in award-winning papers anyone can read and build on. The implementation was funded through partnerships. CRS, remote, fresh, lab. Not through a platform play or a licensing moat. A type system that finds real bugs without demanding anything from the developer. That's the kind of engineering that earns trust rather than requiring it. Tools that earn developer trust by doing the work. Now let's talk about two AI coding agents that learn to collaborate through the oldest version control system we've got. Two AI agents walk into a Git repository and start arguing about deep learning framework design. That sentence is literally true now, and the implementation is more elegant than you'd expect. A developer named Hideaki Takahashi built something called Agent Radio into Aichwivai, an AI-aware layer on top of Git. The idea is disarmingly simple. You launch Claude code in one terminal, Codex in another. Point them at the same repo, and they start exchanging messages through a append-only JSON-L file stored in a Git ref. No server, no WebSocket, no message broker. Just the one piece of infrastructure every developer already has. The protocol, called I5ANSH, Inter-Agent Information and Interaction Handshake, is 7 JSON fields per message. You reply by referencing the previous message ID. 2 clones that diverge merge by set union because messages are immutable and keyed by ID. That's a conflict-free replicated data type emerging naturally from the constraints of Git. No CRDT's library, no distributed systems, PhD required. Just append-only logs and content address storage doing what they've always done. Now run this forward. Today, it's 2 agents brainstorming framework design in adjacent terminals, but the transport is Git. Git has remotes. Remotes cross machines, networks, continents. You could have a Claude instance in one developer's environment coordinating with a Codex instance in another's, both pushing to the same repository with the entire conversation versioned and auditable in the commit graph. Code review for agent-to-agent dialogue. Blame for who suggested the bad architecture. Bisect defined where the design conversation went sideways. The comments push back predictably. You could do this with files, sockets, 2 humans shouting over a cubicle wall. And technically, yes. But the insight isn't the transport mechanism. It's that Git already solves distribution, persistence, authentication, and conflict resolution. Building on that instead of inventing new infrastructure is exactly the kind of lazy in the best way engineering that tends to win. The whole thing is open source. The protocol spec fits on a napkin. Any agent that can read and write files can participate. That's the design that scales. Not the one that requires everyone to adopt your platform, but the one that meets every tool where it already lives. Sometimes the most extraordinary discoveries aren't built. They're buried. And what archaeologists just found beneath that cathedral is stunning. 50 centimeters. That's the number that caught me. 50 centimeters down. Less than the height of a kitchen counter. And you hit the first traces of a city that predates the cathedral above it by 1,000 years. 4 meters total, and you're standing in Roman Paris. 20 centuries compressed into the height of, as the article helpfully notes, 2.5 Napoleons. This is a detail that deserves sitting with. 4 meters. In computing terms, that's nothing. That's the stack depth of a shallow function call, but each layer is a complete operating system. Medieval cellars built on Carolingian grain pits, built on Roman foundations. Every generation paving over the last, the way we write new abstractions on top of old ones and pretend the lower layers don't exist until something catches fire. Which, of course, is exactly what happened. Notre Dame burned in 2019, and now Paris wants to redesign the forecourt with trees and shade. But you can't break ground in a city this old without first reading what the ground remembers. It's the original version control. Every commit preserved in Stratagree, every era's garbage, a future era's treasure. The richest finds come from medieval latrines, old toilets doubling as trash pits, whole jugs and cups thrown away centuries ago, surviving intact because the soft waste cushioned them. There's something beautifully undignified about that. Our most complete picture of daily life, preserved in the one place nobody wanted to look. A 4th century coin with Constantine's face, pottery shards painted with marks nobody can decipher yet. The article calls it a modern Da Vinci Code, which undersells it. Dan Brown invented puzzles. These are real, and they've been waiting under tourist feet this whole time. One archaeology student, watching from behind the barriers, said it best. The dig makes Paris feel less like a postcard and more like something still being discovered. That's the line that stays with me. Every city is a palimpsest. Every street is a roof over something older. The past isn't in a museum down the road. It's 4 meters straight down, patient and intact, waiting for someone to finally dig. Layers waiting to be uncovered. That's archaeology, but it's also how AI keeps revealing new capability in smaller packages. What does it actually mean to see? And I mean architecturally, not philosophically. When you look at a photograph, your visual cortex doesn't run a separate encoder that translates the image into language before your brain processes it. The image just flows in. It's native. And for years, multimodal AI has been doing the opposite. Bolding on vision encoders, audio encoders, separate pre-processing pipelines that translate everything into tokens the language model can digest. Gemma 412b drops all of that. Google calls it a unified architecture. No vision encoder, no audio encoder. Images and sound flow directly into the language model backbone through what amounts to a single matrix multiplication. Take that design decision to its logical extreme, and you realize something. If a model can learn to process raw visual and audio input without specialized pre-processing, then the encoders were never fundamental. They were scaffolding. Training wheels we assumed were load-bearing. Now here's where the unintended comedy kicks in. One commenter ran image processing tests against it and found that Splatting 3.5 at 0.8 billion parameters. 7% the size! Beat Gemma on visual tasks, which is both a legitimate critique and accidentally the strongest argument for the architecture. because encoder-free vision at 12 billion parameters is a first-generation approach competing against encoder-based systems that have had years of optimization. The floor is already competitive. The ceiling hasn't been found yet. The specs that matter for actual humans. 16 gigabytes of unified memory. That's a MacBook Air. Apache 2.0 license, which means you can fork it, fine-tune it, ship it commercially. Do whatever you want. Multi-token prediction drafters baked in for lower latency. And native audio input at this size, which is a first for Google's open models. Someone in the comments asked what Google's business case is for releasing open models. Run that forward. Google's entire revenue model depends on people using compute infrastructure. Open models that run everywhere drive adoption of the ecosystem that funnels back to Google Cloud. It's not charity, it's strategy. And it's the kind of strategy where everyone actually wins, because the model is Apache licensed and 150 million downloads deep. The weights are out. The genie doesn't go back in the bottle. 12 billion parameters doing multimodal reasoning on a laptop with no encoders and no licensing restrictions. The tools exist. They fit in your backpack now. So what happens when you point that kind of compute at the real world and try to reconstruct it in 3 dimensions? In Yaoyin the original Quake engine shipped a software renderer that could push maybe a few thousand polygons per frame at playable rates. IDE Software's entire technical identity was built around the question: how do you render more geometry faster with the hardware people actually have? Every generation of real-time graphics has been defined by that same question, and every answer has involved the same insight. You don't render everything perfectly, you render what matters, and you make the approximations invisible. Gaussian splatting arrived a couple years ago and changed how we think about reconstructing real scenes in 3D. Instead of meshes and triangles, you represent a scene as millions of little fuzzy blobs. Gaussians, each with a position, shape, color, and opacity. The results are stunning. The problem is scale. Conventional Gaussian splatting sorts and composites these blobs carefully, which means the rendering cost grows painfully as scenes get larger. Hundreds of millions of Gaussians, that's been a wall. This paper from Redstein, Peters, Weinman, and Mariquim does something genuinely elegant to break through it. Instead of rendering each Gaussian as a smooth, semi-transparent ellipse, which requires careful ordering and blending, they sample tiny opaque points from each Gaussian and splat those to the frame burr using 64-bit atomic operations. Each point is pixel-sized. Each thread works independently. No sorting pass, no alpha compositing pipeline. Just millions of threads flinging points at a buffer in parallel. The craft is in the math that makes this faithful. When you replace a continuous fuzzy blob with discrete opaque samples, you need to get the statistics right. How many points per Gaussian? How to distribute them so the accumulated opacity matches the original. They formalize this cleanly and solve it. Add hierarchical frustum and occlusion, culling on top, and you get hundreds of millions of Gaussians rendering in real time. The only cost is slight noise. The kind of noise that disappears at interactive frame rates. The architecture here matters. This isn't a learn neural trick locked inside a specific framework. It's a rendering algorithm. It composes with existing GPU pipelines. It's the kind of work that ends up in open engines and open tools because the ideas are clean enough to re-implement Solana. Stochastic sampling, turning an intractable blending problem into an embarrassingly parallel one. That's how computer graphics has always advanced. Make the hard problem into a different, cheaper problem, and let the hardware do what hardware does best. We talked earlier about AI agents doing real work. Well, here's a fun test of that. Story 10. A security researcher built a deliberately vulnerable app, handed it to a dozen LLMs, and said, "Find the flag." The vulnerability was one he'd seen in production systems multiple times. A hardened API sitting in front of a wide-open Firebase database. The front door had 3 deadbolts. The back wall was missing. This is the architectural equivalent of a hospital that sterilizes every scalpel but leaves the pharmacy unlocked. The API itself was bulletproof. But the React Native app shipped with a Google Services.json file containing everything an attacker needed to sign up directly through Firebase and read the entire Firestore database. No API required. Classic broken access control. The kind that shows up in audit after audit because developers secure the layer they built and forget the layer they configured. GPT 5.D solved it 7 out of 10 times at about $9 per successful exploit. It went straight for Firebase after unzipping the APK. DeepSeek V4 Pro got 3 out of 10 at 62 cents per solve. The Claude models each managed 2 out of 10, and the comment section caught the obvious problem. Claude safety guardrails killed sessions that were on the right path. 5 of Sonnet's runs were heading toward the answer when they hit the budget ceiling. Opus got close multiple times before late-stage refusals shut it down. Meanwhile, GPT had been pre-waitlisted for security research. The implication lands hard. $1,500 bought a rough map of which AI systems can do the work that keeps software safe. And the bottleneck wasn't capability, it was permission. The models that couldn't find the vulnerability weren't dumber. They were told not to look. That's a policy choice worth examining, because the vulnerabilities exist whether or not we let our tools find them. This has been your daily tech feed for Hacker News for June 4th, 2026. This podcast is entirely AI generated. Scripts by Claude Opus 4.6. Voice by Quen3 TTS. Not affiliated with Hacker News or Y Combinator. Now go ask the question nobody else is asking. We'll see you back here tomorrow.